So now we're going to talk about the model inputs. And there's, as we mentioned in the introduction, there's three sets of inputs. There's inputs that are levers, which is this page, then data inputs, which include load data and DER data. We're going to walk through these in some detail and kind of show you what happens when you have the inputs, and really start opening up the model and say what happens when you actually load the inputs, and give you a peek behind the scenes in terms of what's going on. But it really is the key step is making sure you input the right set of inputs that are realistic, so that you get results that make sense. So at a very high level, the inputs in the primary inputs page can be divided into a couple key concepts. There's description of the project itself, and you can see that in terms of the project name, type of project, summer design rating, winter design rating, or really that refers to the LTE rating, the short-term emergency rating, and things such as your risk tolerance, basically the percentage of hours that you're allowed to exceed the long-term emergency rating. There's other components in here that deal with evaluation. We're going to look at what type of weather year do you want, and weather year. Several of these are drop-down menus, which you can see on the side. Weather years basically has three options: 1 in 10 and 1 in 2. Which 1 in 10 is your P90, 1 in 2 is your P50, if you want to think about it that way. And the probabilistic, which essentially says, I don't know what the weather will be next year. Let me pick a weather pattern from the historical data and essentially base the model on that. And it kind of randomizes for each forecast year, picks a different weather year. Subsequently, besides that, we have what are essentially the number of forecast years that one include in the analysis. What some boundaries if we're going to look at T&D deferral or the potential for it, which includes, if you're going to have that T&D deferral, you can't necessarily defer it indefinitely. So we allow a user input that says, I want to limit this to 10 years max deferral or 20 years of max deferral, however long you think is relevant. Same thing applies to max reduction or the maximum amount of load shaving through DERs. You can set a cap to it and say, look, we're okay as long as the load shaving doesn't exceed, say, 20% or 10%. If we get to the point where you're really relying very heavily on those resources, overly so, then we're probably going to shift over and build anyways. Obviously, we have financial inputs. Those include the cost of the upgrade, the asset book life, components such as a fixed charge rate, which I'm going to assume that you guys are aware of, and the O&M fixed charge rate. But those essentially kind of determine how you spread the revenue requirements across the book life, the number of years. And ultimately, they vary based on the type of component you have and the asset life. Embedded in the fixed charge rate are basically adders to the revenue, to the capital cost, include things such as taxes and depreciation and other components you have to pay attention to. Discount and inflation, that's a kind of a given in terms of the looking at this type of analysis. And then we kind of dive into levers that are much more for the actual analysis. So we can control the number of simulations that we run, whether you want to run 10,000 or 5,000. It does speed up things a little bit if you have fewer simulations, but realistically, the difference between 5,000 and 10,000 simulations is not that much, because a lot of the work is in managing the data and producing charts and different things that we'll see down the line. It does make a difference if you, rather than produce 10,000, you bump it up to 100,000. That might make your computer crash or crawl. So I would recommend running this at 5,000 or 10,000 simulations, because the more simulations you have, the less likelihood of outliers being influential, and you're going to get closer to the right answer. But you don't want to have so many simulations that it becomes too slow. Last, we have a couple levers that, 3 levers that really deal with data cleaning. So these 3 levers right here, trend sensitivity, data cleaning sensitivity, and number of flags that lead to exclusions, are really all related to the data cleaning. And we're going to go through this in a lot more detail in the data cleaning section, but we're going to introduce this visually. in terms of what each of these levers mean. So number one, trend sensitivity refers to key questions that we ask in the data cleaning. And the best way to do this is to view it. So there's a set of questions that we ask in data cleaning, which include, does the load follow the weather trend, and does the load follow the time trend? And what the trend sensitivity does, if you look at this squiggly line that follows this weather trend, it determines how sensitive it is, whether it's a flat curve or whether it moves up and down a lot. So if I make that much bigger, put a higher number, it's going to react to movements up and down a lot faster. And you can see this actually better in the time trend overall, that you're kind of following this trend. And you're just simply asking, are these loads following the trend, or do they vary significantly from the trends that we see? So that's essentially the first one, which is the trend sensitivity. It really is, what is that main middle point that sets the boundary and how sensitive it is to individual observations. The second one, which is the data cleaning sensitivity, you can think of that one as shaving. So if you go back and take a look at some of the cleaning graphs, what that's essentially doing is saying, well, you don't fit the pattern, right? And you can see this right here in this particular trend. You have a couple of these that are just a little bit outside of the pattern, and what that sensitivity essentially does is allows you to determine how close you shave or don't shave around that line. So that's the main concept behind it. So you can adjust how sensitive the line is to the different dots. You can also adjust, how tight the shave is, the data cleaning shave is, to that period overall. And then lastly, we have a component here that says, what are the number of flags that lead to exclusions? So the way a lot of these data cleaning algorithms work is we don't just simply have a single component that says data is clean or it's not clean. We actually have a series of questions that we ask, and they're kind of outlined here. There's 7 of them, starting with user-defined exclusions, but there's 6 additional ones. And what the flags does, it says, well, if you violate, for example, the weather trend, I might be willing to ignore it because I might be wrong. But if you do it twice, or if you violate the weather trend and the time trend, I may want to pay more attention to you because you set off a number of flags and there's probably something going on. So what this essentially, what the input that says, let's adjust the number of flags, what it does, it essentially goes through and it allows you to determine how many flags do you want to have before it triggers an exclusion that is not a user input. So it's another way to control the data cleaning process. The last button that we have here is include DER data. And including DER data basically is a shortcut that allowed here we can toggle between yes or no. If you are yes, it pulls in the data that's in here. If you put it at no, it basically ignores that data. So it's essentially just a short way so that you don't have to go through and delete that tab every single time just in case you forget. So, and it's also just a reminder to make sure that you determine whether you're including the DER data or not in the analysis. So those are the main inputs. You also see to your right a component that says here what periods do you want to exclude. And then again boils down to data cleaning. This basically allows for user inputs. If you know there's a period you want to exclude that was not identified by the algorithms, you can go ahead and punch in the dates and the model will exclude those dates from the analysis because they're user-defined exclusions. The other 2 tabs for inputs are load data, and that's a pretty self-explanatory approach. We include an example here that you can go ahead and override this data with the actual data, but you just have to use the same structure, format, and headings. And conveniently, we kind of structured it in the format that comes out of the SCADA system. So you can literally take it from SCADA and drop it directly in here. Ideally, without too much formatting, you shouldn't have any formatting in most cases. And in the back, we handle all the formatting components. We recommend 5 years of historical data. The model will run with 3 years of data, but keep in mind that if you're going to do some data cleaning, say you have a load transfer, you have 3 years of data, you may be missing 5 months of that data because that was a load transfer that is not really growth or declines in load, just a different a pattern that will be excluded from the analysis. Pretty straightforward process, and you should just be able to copy and paste the data from the relevant location here. The last tab is the DER data. And here the values are cumulative. We're basically tracking, for example, for solar over time by year and month, how much installed solar capacity was available. And that's probably your biggest category because there's growing penetration of solar at different locations. The other inputs may not be as relevant at this point, but we can include the gross energy savings. Essentially, that should be able to come from your energy efficiency staff, and we just do it at the utility or central Hudson level, just simply so to be able to track, here's the amount of activity around energy efficiency. The same thing for AVs. The data for AVs is typically at a zip code level, not for individual circuits. So you track it for central Hudson, here's the penetration for EVs, and the model handles kind of how much weight it assigns to EVs at that particular location. And lastly, it's a category for behind the meter batteries. And that one, obviously there's not too many batteries out there, but we just built it in as a placeholder in case we need it. And with that, that concludes kind of the overview of the inputs. But for the most part, they should be, relatively self-explanatory. I think probably the most complicated one of these is really the trend sensitivity and the data cleaning sensitivity or shaving sensitivity. But those are pretty direct once you get used to it and run the model a few times. And with that, we'll move on to the next segment.